Good morning. So we were discussing electron gas theory or electron C theory. Okay, and we have discussed this. Now we have to explain metallic properties. Okay, metallic properties such as say it is electrical conductivity, thermal conductivity, okay, then lustrous, okay, electrical conductivity, thermal conductivity, then metal are lustrous, okay, then metals are hard, etc. Okay, using this electron gas theory. So electron gas theory we have understood. Now we will be explaining, okay, using electron gas theory, that how metals are electrically good conductor, how it is thermally good conductor, how metals are lustrous, okay, why metals are hard, why metals are means having more tensile strength. Okay, so come to the first property, that is electrical conductivity. Okay, I told you what is electron gas theory. Let these are metals. Okay, so what happens if it is a metal, then outermost electrons or valence electrons are loosely held, okay, with this atom of metal. Okay, so what happens, they get separated from the metal. So as electrons came out of the atom, as valence electrons came out from the metal atom, what happens, a positive charge, okay, a positive charge is assigned to this metal atom. So we say all these are what, M plus, all these are M plus, means kernels. I told you kernels, all these are kernels. Okay, and I told you electron C, okay, electron C is present everywhere. Okay, means the electron which came out, the valence electron which came out, okay, from this metal atom is in bulk or more in numbers. That's why these are known as what, these are known as electron C. I have told you. Now you can see all these are electrons present in bulk, so these are what, these are electron C, and these are what, these are kernels. And I told you kernels are generally fixed, and these electrons C are always moving. Okay, so we are going to explain electrical conductivity on the basis of electron C theory or electron gas theory. Okay, so what happens, as electric field is applied or as potential difference is applied, what happens, these electrons okay, which are randomly moving, okay, starts moving in, we say, a defined direction, okay, well defined direction, okay, means if you are connecting a battery, then in battery there is a positive terminal, there is a negative terminal. Positive terminal is connected with positive end, negative terminal is connected with negative end, okay. So what will happen, if potential difference will be applied, then these electrons which are moving randomly will set into, okay, means constant motion, okay, and the flow of electrons will be in a particular direction. Then the flow of electrons will be in a particular direction, then, okay. Then if there will be flow of electron, then we say it will be conducting, okay. So on the basis of electron gas theory, what I told you, when you will apply potential difference or electric field or electric current across these, okay, metals which is present in atoms, which is present in forms of kernels and electrons C, these electrons which are randomly moving will move in a particular direction, okay. And movement of electron, we know it is electricity, means the metal atom will start conducting, okay. So electrical conductivity can be explained by this electron gas theory, okay. As I told you, means I am going to write here metal atoms are present as kernels and electron C okay, and due to strong electrostatic attraction between these kernels and electrons, okay, metals or metal atoms are present as kernels and electrons C, and due to strong electrostatic force of attraction between these kernels and electrons, okay, they bind up by a bond called as metallic bond. Okay, then we will write as the electrons present in electron C okay, as the electrons present in electron C is randomly moving when potential difference is applied or when electric current is applied on metals, these electrons starts moving in a particular direction it starts moving in a particular direction, okay, thus making the metal conductor in nature. Got it? So electrical conductivity can be explained on the basis of electron gas theory. Now come to thermal conductivity. Thermal conductivity. Okay, so what happens as heat is applied or as heat is supplied to the metal, as heat is supplied to the metal, okay, some electrons present in that particular region, where heat is being applied, where heat is being supplied, okay, a heat thermal conductivity when not as right here when heat is supplied to the metal, some electrons present in that particular region where heat is being supplied, okay, absorbs heat energy and this results in increased kinetic energy of the electrons. Means what? Suppose we are heating this metal, okay, this is metal, so this is in this metal atoms are binded through metallic bond, means kernels are present there and electrons C are present there. Suppose we started heating this region, okay, then what will happen? This heat, okay, will be absorbed by this electron, okay, so heat is a form of energy, so what will happen? Kinetic energy of this electron, okay, or the kinetic or energy of the electrons which is present in this region will be increased. So as the kinetic energy will increased, okay, then what will happen? The motion of the electrons will be fast, so it will collide with other electrons, okay, we say more fast, okay. So what will happen when this will collide with say this electron? So it will transfer its kinetic energy, it will transfer its extra kinetic energy which is given by the heat, okay, to the adjacent electron. Then the adjacent electron, after getting the kinetic energy, extra kinetic energy, will collide with other electron, and this process will be continue, and this will be result, okay, in the we say means by this way, okay, whole of the metal will be heated, okay, and we say thermal conductivity is shown here, okay. So now we will write, we have written when heat is supplied, to the metal, some electrons present in that particular region where heat is being supplied absorbs heat energy, and this results in increased kinetic energy of the electrons. Now, electrons having more kinetic energy will collide with the electrons having less kinetic energy. Getting this? Electrons having more kinetic energy will collide with the electrons having less kinetic energy, and during collision transfer of kinetic energy will take place. Okay, and we know energy is transferred from higher energy source to lower energy source, so it is very obvious that kinetic energy, okay, will be transferred, okay, from the higher kinetic energy electrons to the lower kinetic energy electrons. So I am not going to write this, okay, you can simply understand this, okay, and this process continues. This process continues till the metal is, so don't write this, and this process is continues making the metal a thermal conductor. Okay, now we have discussed why metals are electrically conducting, okay, or good conductor of electricity, why metals are good conductor of heat using electron gas theory. Now we will be understanding why metals are lustrous, why metals are shining. Okay, so right here, metals are lustrous because the electrons present in the electron C, okay, absorbs photon from light. Metals are lustrous, okay, because the electrons present in the electron C absorbs photon, okay, of frequency equal to the frequency of incident light. Getting this? Metals are lustrous. Metals are lustrous. We are going to explain this, okay, on the basis of electron gas theory or electron sheath theory, okay, because electrons present in the electron sheath absorbs photons of frequency equal to the frequency of incident light, okay. Then after absorbing photon, electrons starts radiating okay, and during the radiation electromagnetic radiations are produced. Okay, and during the radiation electromagnetic radiations are produced, and in this way metals are lustrous. Got it? Electrons are present in electron sheath as sunlight, okay, means when it is exposed to sunlight, then the electron present in electron sheath absorb the photon present in sunlight, and once the photon is absorbed by the electron, then electron getting, okay. And one more thing I have written here, the photon, okay, which it absorbs is of frequency equal to the frequency of incident light. This is important, okay. Then when it starts radiating, then what happens? Electromagnetic radiations are evolved, and we know if electromagnetic radiations, okay, are is given out, then we say certain color will be showing. So we say here, and in this way metals are lustrous, okay. Now come to why metals are hard. So metals are hard because there is strong force of attraction between the kernels and the electron sheath okay. Means hardness is due to the strong force of attraction between the kernels and the electron sheath, okay. Means strong the metallic bond formed, strong will be or hard will be the metal. So we say hardness can be increased, okay. Hardness increases, hardness of metals increases, hardness of metal increases as the force of attraction between kernels kernels and electron C increases. Kernels and electron C increases. Okay, how force of attraction between kernels and electron C will increase? Okay, as there will be more electrons present. Okay, more electrons present means simply if it is sodium, then sodium can only we say sodium can give one electron only. Okay, if it is magnesium, magnesium can give two electrons. Okay, one atom of sodium can give one electron. One atom of magnesium can give two electron. One atom of aluminum can give three electrons. So number of electrons can be increased. Okay, it means write down. It is sodium. So sodium can form Na plus one electron. Magnesium can form Mg2 plus 2 electron. Aluminum can form Al3 plus 3 electron. So sodium can give 1 electron, magnesium can give 2 electron, aluminum can give 3 electron. So more the number of electron will be given, means more the electrons C will be there. So more will be the attraction between the kernel and electron, between the kernel and electron. Okay, and we say more will be the force of attraction between them. So more will be the force of attraction, then harder will be the matter. Okay, now come to molecular orbital theory. Molecular orbital theory. It is molecular orbital theory. So right here, molecular orbital theory. In short, it is written as MOT. MOT. Okay. And in chemical bonding, in class 11th, you have studied this molecular orbital theory in detail. Okay. So I am just going to remind once. Okay, what is molecular orbital theory? Okay, molecular orbital theory is atoms of different, or we say different atoms, or maybe same atoms. Okay, atoms combined together. Okay, to form molecular orbital. Okay, what is this? Atoms combine to form molecular orbital. And the number of molecular orbital formed, the number of molecular orbital formed is equal to the number of atomic orbital participated. Okay.